Here are the two solutions. Great work if you found both of those. First, we split up each of these numbers into two factors. We want to make sure that one of the factors is the largest square number that divides into it. For the first one, we know the square root of 16 equals 4, and then we're left with multiplying it by the square root of 3y. We take the square root of 4 to get 2 times the square root of 3y, and we take the square root of 9 to get 3 times the square root of 3y. Be sure you keep the signs the same as you work. Now we have like terms since each one has a square root of 3y. We add 4 and 2 and subtract 3 to get 3 times the square root of 3y. For the second problem, we start by splitting up 8 into 4 times 2, and we split up 32 into 16 times 2. For our numbers, we take the square root of 4, which equals 2, and this 2 stays inside of our square root since it doesn't appear twice as a factor. For the variables, we want to remember power divided by root. We take the power of 2 and divide it by 2 to get 1. This means x to the 1 appears outside of our radical. For y, we'll do 3 divided by 2, because our index is a 2 here. We know 3 divided by an index of 2 equals 1 remainder 1. This means 1y comes out and 1y stays in. We saw this before when we were simplifying roots earlier. We use power divided by root, and this number indicates the power outside of the radical, where the remainder indicates the power inside the radical. For our second radical, we take the square root of 16, which equals 4. The 2 stays inside of the square root, and now we need to simplify y to the third power. We use power divided by root, so 3 divided by 2 equals 1 remainder 1. So we'll have 1y on the outside and 1y on the inside. We multiply the numbers together in front of each radical to get 6xy times square root of 2y minus 8xy times the square root of 2y. Now we subtract these two radicals. We use 6xy minus 8xy to get negative 2xy times the square root of 2y, our final result. Keep in mind there were two reasons why we could subtract here. We subtracted because the radicals were like, and we subtracted because these polynomials were like terms. We're really packing on the algebra now.